Welcome to the DIY Honda Garage channel. The DTC P2A01 refers to a specific malfunction concerning the secondary heated oxygen sensor, often abbreviated as secondary HO2S or sensor 2. This sensor plays a crucial role in monitoring the exhaust gases and sending pertinent data back to the powertrain control module or PCM, ensuring optimal engine performance and emissions control. The PCM is responsible for processing the data from various sensors, including the secondary HO2S, to adjust engine parameters accordingly. When this sensor indicates an output voltage lower than the specified threshold, the PCM identifies it as an abnormal condition and subsequently stores the DTC. The Diagnostic trouble code assists technicians in pinpointing issues related to the secondary HO2S circuit and aids in the troubleshooting process. In this guide, we'll explore detailed troubleshooting steps to efficiently address the DTC P2A01 in the 2023 Plus Honda CR-V. The DTC P2A01 error centers around the secondary heated oxygen sensor, commonly referred to as the secondary HO2S or sensor 2, which is essential for measuring oxygen concentration in the exhaust gases. This sensor is typically located downstream of the catalytic converter on the exhaust system, allowing it to assess the effectiveness of emissions control systems. The primary role of the secondary HO2S is to provide feedback to the powertrain control module or PCM to fine-tune the air-fuel mixture and facilitate optimal combustion in the engine. If the secondary HO2S output voltage drops below the manufacturer's specifications, this indicates a circuit performance issue, prompting the PCM to log the diagnostic trouble code. The error indicates that the system is not functioning properly, which can lead to decreased vehicle performance and increased emissions. Understanding where these components are located and their specific function is vital for effective troubleshooting of the error. To address the DTC P2A01, it is essential to identify the possible causes. One of the primary suspects is a faulty secondary HO2S, which could fail to provide accurate readings, leading to performance issues. Another potential cause could be an open circuit in the wiring that connects the secondary HO2S to the PCM. This may occur due to wear, damage, or disconnections in the wiring harness. Additionally, a short circuit to ground in the SO2 circuit can also trigger this error, as it would affect the voltage signal reaching the PCM. Understanding these causes is crucial for pinpointing the source of the fault and resolving the DTC accurately. Recognizing the symptoms associated with these issues can also help in diagnostics, ensuring that the root of the problem is identified effectively. When the DTC P2A01 is present, a few symptoms may become noticeable by the driver. The most common symptom is the illumination of the check engine light on the dashboard, signaling that the engine management system has detected an issue. Additionally, a driver might experience reduced engine performance, as the engine might not operate at its optimum level due to inaccurate sensor readings, affecting fuel efficiency and emissions. Increased emissions are another significant concern, as the secondary HO2S plays a pivotal role in the vehicle's emissions control strategy. If this sensor operates improperly, it may fail to help the engine achieve its intended emission standards. Being alert to these symptoms can assist drivers and technicians in taking timely action, thus preventing further complications and costly repairs. The first troubleshooting step for addressing DTC P2A01 requires starting the engine and monitoring the system's response. It is essential to hold the engine speed at approximately 3,000 RPM without any load on the engine, meaning the vehicle should be in either park or neutral. This elevated RPM allows for the proper activation of engine components and systems, facilitating the assessment of sensor behaviors. While maintaining this RPM, the technician should observe the HDS, or Honda Diagnostic System, specifically for the OBD status related to PGM-FI, to confirm whether DTC P2A01 is still registered. This observational step provides vital real-time data, helping to verify whether the issue persists under elevated engine conditions. If the DTC is still present after these checks, further investigation is warranted. The second step in troubleshooting DTC P2A01 involves inspecting the secondary HO2S circuit and related connections. Begin by checking the SO2 circuit, which is responsible for transmitting the sensor signal to the PCM. It's crucial to evaluate the resistance in this circuit, ensuring that it is less than 1 ohm, which indicates that the wiring is intact and functional. Concurrently, inspect the SO2SG circuit, labeled as the signal ground for the secondary HO2S, to ensure it also reads below 1 ohm. These checks are vital, as any open wiring could lead to erroneous readings, thus triggering the DTC. Perform these assessments while disconnecting the PCM and secondary HO2S connector to properly isolate the circuits. Confirming the electrical integrity of these connections is paramount in ascertaining whether the wiring faults are the root cause of the DTC P2A01. In this step, the focus shifts to inspecting for any shorts to ground within the secondary HO2S circuit, an important procedure in addressing DTC P2A01. Using a multimeter, check the resistance of the SO2 circuit to ground, confirming that it registers more than 1 megaohm. This high resistance reading indicates that there is no short circuit present, allowing the signal from the secondary HO2S to function correctly. Perform the same test for the SO2SG circuit. It should also exhibit more than 1 megaohm of resistance to ground. If either of these circuits fails to meet this requirement, it is indicative of a short, which must be repaired before resolving the DTC. This methodical approach highlights the need for thorough inspection of the electrical systems connected to the secondary HO2S, ensuring that the entire circuit is functioning as required. After inspecting the circuits, the next step involves conducting an inspection of the secondary HO2S itself. Since a direct testing method may not be available, replacing the defective sensor with a known good component is a widely accepted approach. By installing the known good secondary HO2S, technicians can then attempt to reproduce the initial failure that led to the DTC P2A01. If the DTC reappears after installation, this may indicate that the issue resides within other related components, such as wiring or the PCM itself. However, if the DTC clears and the symptoms resolve, then it confirms that the secondary HO2S was at fault. This step is crucial as it helps to eliminate possibilities and focus on the true root cause of the issue, thus ensuring a reliable repair of the vehicle's system. The final troubleshooting step involves conducting a detailed inspection of the powertrain control module, often abbreviated as PCM, if earlier inspections do not yield conclusive results. If the previous components have been confirmed as functioning properly, a thorough check of the PCM inputs and outputs is necessary to ascertain its operational status. This process involves using testing equipment to evaluate whether the PCM is processing data accurately and controlling outputs accordingly. Should any abnormalities in these functions be detected, it may confirm that the PCM itself is the source of the problem. Remember, if the secondary HO2S and associated circuitry are verified as normal, the PCM's role as the primary control unit must be scrutinized closely. The goal here is to ensure that each component is not just functioning independently, but also communicating correctly within the overall vehicle system. After conducting all necessary repairs related to DTC P2A01, the final repair verification step is essential for ensuring the effectiveness of the solutions implemented. Start this process by clearing the diagnostic trouble codes from the vehicle system through the HDS, Honda Diagnostic System. This step resets the system, allowing for fresh monitoring and helps in determining if the repair has resolved the underlying issue. Following this, perform a test drive under various driving conditions to observe the vehicle's responsiveness and performance. It's important to keep an eye out for any reappearance of the check engine light or abnormal engine behavior during this drive. If the vehicle operates normally without any fault codes being recorded after this verification process, it indicates that the repairs have been effective and the issue with the secondary HO2S circuit has been resolved satisfactorily. Preventive maintenance plays a crucial role in minimizing the likelihood of future DTC P2A01 occurrences. First and foremost, maintaining regular inspections of the vehicle's wiring and harness connections can help identify any wear, corrosion, or damage that could hinder the performance of the secondary HO2S and its associated circuits. Attention should also be directed toward the connections at the sensor itself and the PCM, ensuring they are clean, tight, and free from contaminants. Furthermore, routine checks on the vehicle's exhaust system can prevent potential blockages that could affect sensor readings. By maintaining these components proactively, vehicle owners can ensure optimal performance and extend their sensor life, which contributes to improved fuel efficiency and reduced emissions. These small operational checks can make a significant difference in the long-term health of the vehicle's emission control systems. In summary, the DTC P2A01 indicates significant issues concerning the functionality of the secondary heated oxygen sensor and its associated circuitry. Following a structured troubleshooting approach is essential to accurately diagnose and resolve the errors indicated by this code. Each step from initial inspections to recognizing symptoms is critical, as they help in identifying whether the fault resides within the sensor, wiring, or the PCM itself. Moreover, implementing preventive measures such as routine inspections and checks can further ensure the longevity of these components and the overall vehicle performance. Addressing the issues related to the P2A01 code not only enhances vehicle efficiency, but also contributes to reducing harmful emissions, aligning with environmental standards. Remaining vigilant and proactive about potential issues will help maintain the reliability and performance of your Honda CR-V for years to come. Please like and subscribe to the channel. See you next time.